Today's lesson is a continuation of the last one on factoring polynomials. In the last lesson, we focused on pulling out greatest common factors, and we also focused on factoring trinomials that had a leading coefficient of 1. So everything started off x squared. In today's lesson, we're going to continue talking about greatest common factors. And now we're going to start factoring trinomials that have an a greater than 1. So our polynomials are going to start off with 2x squared or 7x squared, and we're going to factor those. So how do I factor polynomials? Continues to be our essential question today. Hey, remember that whenever we have a greatest common factor, that has to come out first. If I look at the greatest common factor of 15 and 3, it is 3. And I have to now divide each term by this greatest common factor. 15 divided by 3 is 5. Keep the x and the y. Plus 3 divided by 3 is 1. Looking at our next example, 4, 24, and 8 have a greatest common factor of 4. X to the 5th, x cubed, and x have a common factor of x. In terms of variables, it's always your smallest exponent that works out to be your greatest common factor. So now I have to divide each term by 4x. Let's see here. The 4's will disappear. X to the 5th divided by x is x to the 4th minus 24 divided by x is 6. X cubed divided by x is x squared, plus 8 divided by 4 is 2, and the x's cancel out. All right, looking at the next one, 13 and 3, there's no greatest common factor there. But A, B, and C can all come out of each one of these terms. Alrighty. I'll have to keep the 13. A squared divided by A is A. B divided by B is 1. C divided by C is 1. Minus 3. A divided by A is 1. B divided by B is 1. C squared divided by C is C. Looking at our next example, I've got a greatest common factor of 5. As I divide each of these terms by 5, I'm left with 5x squared minus 7x plus 2. Next, whenever your x squared term has a negative coefficient, pull that negative out, even if it's just a negative 1. 3x squared plus 12x minus 14. 3, 12, and 14 do not have a greatest common factor, so I'm done. For our last one, we have a greatest common factor of 6x. 30 divided by 6 is 5, and x squared divided by x is x, minus 24 divided by 6 is 4. Always, always check to see if there's a greatest common factor before doing anything else. Now, we talked last time about standard form of a polynomial and identifying A, B, and C. A is my coefficient for x squared, B is my coefficient for x, and C is my constant. A is my coefficient of x squared. B, technically, there's a plus 0x on here. So B is 0, and C is my constant. A is my coefficient of x squared. B is my coefficient of x, and C is 0 in this example. Technically, we could add plus 0. Now, all of this is a review from the last lesson. Before we go into slide and divide as a method for factoring polynomials, this is a method you only use when a is greater than 1. Okay, so first off, we have to factor out any common monomials. And if a is negative, we have to pull out a -1. So in this case, I can factor out a 2, leaving me with 2x squared plus x minus 3. I want to multiply a and c. A equals 2, c equals -3. So a times c will be -6. And one of the things that I do with this is the slide in slide and divide. So I have 2 times x squared plus x minus 6. I want to find the factors of -6 that will add up to 1. Because now we're factoring the way we did last time. We're going to have x times x. And we need to figure out 6 is 1 times 6 or 2 times 3. Because the 6 is negative, I need to look at my b. b is positive, so the larger number has to be positive. Which pair will add up to a +1? And that's -2 and +3. Now at this point, we have 2 times x minus 2 times x minus 3. And here comes the divide in slide and divide. I have to divide by a. So, at this point, we can't have fractions when we factor. I'm going to keep the 2 times x minus 2 divided by 2 is 1. That's the easy one. The next one's a little trickier. 3 divided by 2 is a decimal. We can't have decimals when we factor. So we slide this 2 back up in front. 2x minus 3. Slide and divide should really be called slide and divide and slide, because you end up sliding a second time at the end. Let's take a look. No common factors. I'm going to slide my 2 down here, and I'm going to factor n squared plus 3n minus 18. Well, n squared has to be n times n. Now, -18 is 1 times 18, 2 times 9, 3 times 6. I know one of these has to be negative, so I look at the middle term. The middle term is positive, so my bigger factor has to be positive. And here's my pair that will add up to a +3. So -3 plus 6. Now divide. You have to divide by the same number that you started off by sliding. So I have to divide by 2. Okay, and here's that slide back. Because 3/2 won't simplify, I have to slide the 2 back in front. N minus 3 times n, 6 divided by 2 is +3. And I'm done. Let's look at another one. No common factors. So I want to slide my 5 down here. N squared plus 19n plus 60. All right, n squared is going to be n and n. 60, 1 times 60, 2 times 30, 3 times 20, 4 times 15, that's the pair I want, because 4 plus 15 is 19. Now I have to divide by 5, because I started off sliding the 5. 4/5 is not going to simplify. So this 5 has to slide back up front. N plus 15 divided by 5 is 3, and I'm done. another one. 9, 24, and 12. There is a greatest common factor. I've got to pull out a 3 before I can start. I'll have 3n squared minus 8n plus 4. And this is going to equal 3 times something when I'm done. Now I'm going to slide this 3 to the 4, so I'm going to factor n squared minus 8n plus 12. It's going to be n, it's going to be n, it's the 12 I've got to watch. Right, 1 times 12, 2 times 6, and because this is positive, if my 2 and my 6 are both negative, I'll get the negative 8. Divide by a, which was 3. Slide this one back in front. 3n minus 2, n minus 2. Final answer. Yet another one. This one starts off with a negative, so I know I have to pull out a negative 1. 5, 16, and 3 don't have any other common factors. So I'm going to start by pulling out a negative 1, and I'll have 5x squared minus 16x plus 3. So my final answer is going to be negative 1 times something times something. 5 times 3 is 15, so x squared minus 16x plus 15. Well, x and x. And 15 is 15 times 1. So minus 1 minus 15, that'll give me a negative 16 there in the middle. Divide by the 5, because that's what I used to slide at the beginning. And I'll have 5x minus 1, x minus 3. Final answer. Your final answer has to include the greatest common factor. That's a common mistake a lot of people make, so be careful with that. Next example, 6, 4, and 16, I can pull out a 2. I can also pull out an x squared, leaving me with 3x squared plus 2x minus 8. So my final answer is going to be 2x squared times a binomial times a binomial. Let's look at x squared plus 2x minus 3 times 8 is 24. So I know I'll have x and x. 24 is 1 times 24, 2 times 12, 3 times 8, 4 times 6. Aha! The middle term is positive, so the biggest number has to be positive. Negative 4 plus 6 will equal 2. Now divide by a, which was 3. Remembering to slide it back in front when it won't divide nicely. 3x minus 4, x plus 2. Ooh, the next one doesn't have 3 terms. I better hope it's a perfect square minus a perfect square. What do you think? I think so. Let's see. 7x plus 4, 7x minus 4. I like that one. No slide, no divide necessary. I know my pattern. I am done. Oh, I like the next one too. The coefficient in front of a is a positive 1. So let's see. X, 14. 1 times 14, 2 times 7. I look at the middle and it's positive, so the bigger number has to be positive. Negative 2, positive 7. I'm done. Next up. 9n squared, negative 12, positive 4. No common factors there. So I'm going to slide the 9 down to the 4. N squared minus 12n plus 36. N and n. So 36 is 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. And because it's positive, they both have to be negative in order to get a negative in the middle. So minus 6 minus 6. Divide by your A. Ooh. 6/9 is 2/3. So I can write 3n minus 2 times 3n minus 2, or 3n minus 2 quantity squared. Either answer is considered correct. So when C is negative, what do we know about the two factors? We'll have one positive and one negative factor. When C is positive, they are either both positive or both negative. Sometimes you can't factor the polynomial. Let's look at this one. 2 is just 1 times 2. Is there any way to add that together to get 4? No. This is prime, because you can't do it. Let's look at this one. It's only 2 terms, so it would have to be a perfect square minus a perfect square. 2 and 3 are not perfect squares, so prime. In this one, we have 2 perfect squares, but we have addition. We can't factor addition with 2 perfect squares, so prime. At this point, you need a summary and a couple of questions.